I'm going to talk about Dredge. Dredge is an open source tool that we created based on a particular condition that I think is happening in Argentina, but as far as I have been seeing, it's not only happening in Latin America, about the lack of preparation that companies have regarding cloud security and incident response. So I'm Santi, I'm from Argentina. This is my third time in here. This is my third time presenting in Virus Bulletin. And I think it's like super nice. It's like my home away from my home. So I thank you all of that for that. Argentina is right there. For you, for who don't know where it is. And we are now basically because we are the current World Cup winners and because of our president that you must have known him. So yeah, why Dredge? In Argentina and in Latin America, we use this like framework to do incident response. It's a basic theoretical framework when you can see like you should have like a preparation, a detection analysis, methodology, then the containment, and then the post-incident activities whenever something is happening, right? And this is like, I think it's worldwide, but what happens in Latin America is that most companies don't prepare enough because time to market and they need to like go to production as fast as they can, especially small companies and startups. So they try to apply directly the detection part of the framework, and some companies don't even do that. So when they call us for an incident response methodology or because they got compromised or because they got an alert that they don't know how to respond, they don't have logs, they don't have security protections in practice, they almost don't know from where to get that information. So in order to help them and also to help us with the analysis, we created this tool. But why do companies do this, right? This way, why they are not preparing for the attacks if we are all aware that there are a lot of attacks happening all the time, and that if we know that every day there are more attackers on trying to compromise environments, especially cloud environments. The first of all is like this is how much it costs, more or less. These are estimated values on how much it costs for you to get a SIM in Latin America. So the top value is what it costs for you to get the logs in S3, and the other values are the most typical vendors that we can find in Argentina. And as you can see, it's like a huge amount, it's a huge difference. And most companies are like, I don't even make that amount of money per year, and I need to pay that only for getting the logs. And it's even worse when we add to that the alerting part of the SIM. So it's like, okay, I need to pay 10K for getting the logs and also need to pay another 5K to get alerts that I don't even know how to respond, because on the top of that, they need to pay for an analyst to work with this. So there is a lot of things that should go on, and maybe they don't make that much money. And this is how much it costs a cloud security posture management. A cloud security posture management is a tool that allows a company to understand what are they doing wrong regarding like their AWS tenant, their GitHub account, or whatever. There are open source versions, but they are not as great. They fill you with false positives, and it's really hard to maintain from a startup perspective because the amount of information that they give, it's not prepared for a small company. So they think about like major and big companies, and with that, they are focusing in small details that they don't even know how to prioritize. And all of that is only the technology part of the Venn diagram, right? They also need to focus on personnel, on people, in processes. So at the end of the day, implementing a security strategy is like super hard. And they say, okay, if I got compromised, that's it. I need to make money first, and then I would see. But then they got compromised, and they call us. And we are like facing this approach of trying to respond to a security incident without the proper preparation. Luckily for them, cloud providers are not secure by default, but they have a lot of features that allow us to get information no matter what they got prepared or not. For example, if we have memes about something, it's because it's a problem, and there are a lot of memes. If you look for memes regarding like implementing SIEM or false positives, it's like a ton. So this is a real problem, and I think it's not only for Argentina. So what does Dredge do? Dredge basically has 4 models. The first one is log retriever. Log retriever allows you to get logs from different cloud tenants without bothering that much about how to get those logs. This is a collection of scripts that we use on a daily basis to respond to incidents that we pack all together for our analysts to be more easy for them. And we end up like publishing this on GitHub. So this is free and open source. You can download it by the QR code if you want, and you can contribute or submit feedback. I will be more than happy for that. So with log retriever, for example, you can get CloudTrail logs in AWS that maybe you haven't enabled them. In AWS, CloudTrail logs are those logs that are used to get API calls to the tenant. And most companies don't even enable them, so they cannot see by default what's going on within their tenant. So if somebody like create an IAM user or a credential and they are not aware of that, and you don't have CloudTrail enabled, you are not going to see that. But by default, AWS has a feature that's called event history that's always enabled by default. But you need to retrieve that through the API. So with Dredge, you can query the API and get that information in an easier way. You can also like define a time frame and get only the logs that you need for that time frame. The problem with the APIs from AWS is like it's not trivial to query for that specific time frame. So we did a Python script to facilitate that. It has also a threat hunting model that allows you to segment those queries and to get specific data that you want. For example, if we were talking about this IAM user creation for persistence, for example, you can use the threat hunting model to get that specific API call to understand if you were compromised instead of only trying to look for the logs. We have an incident response model that allows you to respond to the incident. So if we executed a threat hunting exercises with Dredge, and we understood that there was a new API credential, a new IAM credential that was created by a threat actor, or maybe by an employee, and that should be there, we can disable the access key, we can delete the IAM user, we can isolate the EC2 server, we can do a lot of stuff that is not trivial, it's not hard also, but when you sum up all the APIs that you need to understand in order to respond to an incident, plus the adrenaline of not knowing what's going on, it helps a lot. Also, what we can do with this, for example, if we are working on an incident and the client says, I don't have logs, yes, you have. Please give me access to your tenant. No, I cannot because of compliance. Okay, run this script and give me the output. And with that, we can process the information without trying to teach them in the middle of the data breach or the incident how to get API logs from AWS. And also, the last model is cloud status. That is a cloud security posture management for incident responders. So it will trigger against the cloud environment and give us the information we need for the incident itself. It doesn't bother about small stuff that is not exploited on the wild or a lot of information that we don't need in that moment. So it allows us to get that tactical information that we need in the middle of an incident. So let's set up Dredge. This is a config file. As you can see here, this is all this information is in the repo. So if you go to the repo, you're going to see this better. But basically what we have here is like, we can set API keys for shutdown integration or for virus total integration. we can set the specific time frame, and we can set all the logs that we need to retrieve at the same time. So if, for example, we need to retrieve 10 accounts from AWS at the same time, we can set those 10 profiles and make Dredge retrieve that information at once without us needing to change on the tenants or changing the roles and the profiles. So this is a quick demo on, it's small yet. So what are we doing here is we list all the S3 buckets to understand in which one we had logs, and we are going to set up the config file. We are going to we're going to enable the log retriever in AWS, and we're going to set the ALB log file in the bucket configuration. And with this, when we launch Dredge, it's going to target the config file and it's going to start retrieving the logs from that file. We can execute this using the config file, and also we can execute this as a CLI command. So whatever suits us better for that reason. So there it's going to start retrieving the log files from the S3 bucket. If you have worked with S3 buckets, you would know that the folder structure is very awkward to work with when you are getting the logs. So this is like, this streamlines that process in an easier way. So let's talk about a TTP, about how attackers like Lapsus get information from a GitHub repo. What they can do is, for example, they can clone the repo if they got access to your GitHub account, and with that, they would get all your PII or your data. We have seen this in real life, and it's something super easy for them to do. The difficult thing with GitHub logs is first, you need to enable them, and in order to enable them, you need to have an enterprise account, but we cannot do anything about that. But the other difficult thing is that when you try to retrieve those logs from the web console, you are not going to see everything. You're going to see important data like this, like my user changing from location to location, but you're not going to see the git fetch, the git clones, the git forks that are the logs that we need to understand if the information was leaked. So in order to get that, we need to execute an API call against the GitHub API, and again, it's not trivial. So with Dredge, we can do a demo like this. So here we are going to execute Dredge as a CLI command. We are going to use the module log retriever, the LR. We're going to target with the GitHub token as authentication. And we're going to say that we are going to get the organization logs from Solidarity Labs. As you can see there are a lot of different logs with the source IP that we were not seeing before. And we have like other types of information regarding what's going on with the repo, like the fetch, the forks, and all that information. We can also retrieve enterprise log, changing the flag from org to end. And this is going to give us different types of logs based on everything that is in the enterprise environment. So for example, here we have, besides the location that we were seeing before, we have like the actor, and here we have the action, that's git push, for example, that we weren't seeing that in the web UI. So that's why it's important for us to be able to see this. Again, if the client doesn't know how to get these logs, we can say, install Dredge, run this command, give us the output, and for us would be much easier than start trying to explain to them that what they are seeing is not what they are seeing and all that stuff. This is not. Okay, I will continue here because I don't know where the PowerPoint went. Okay. Other things that we can do with Dredge are, for example, we can execute the cloud status command to get the information about the IAM users in the account, for example. Here what we're going to do is to execute the cloud status model. So we change the log retriever for the cloud status. We're going to authenticate against AWS with a profile and a region. A Dredge is going to run, and it's going to let us know what are the IAM users in the account and what information do we need for the incident response practice. So for example, here, we can see different IAM users, if they have MFA enabled, if they have access keys, if the access keys are active or not. And also the other important thing is what was the creation date. That for incident responders is super important, and we don't have that all the time. These are the TTPs that we can see related to IAM user and with persistence. As you can see, you can create credentials, you can create users. This is all things that we see in real time and that we can create, for example, SSH keys. So whenever we list EC2 instance, we want to see, for example, the creation of SSH keys and in what was that time. For incident response, we can see the TTP of executing commands in an EC2 server. So whenever a server is compromised, we can see that they are trying to execute things from there, and we need to isolate them. The difficult thing in AWS, for example, is that when you try to isolate a server with a security group, all the existing connections are going to still there. So you need to cut those connections before moving that for a forensic security group. So this requires you to execute 4 or 5 API calls that we have automated in this demo. So here we're going to list EC2 instance. I hope it sees because on how the response of the CLI, we're going to get some information. So whenever we are getting the EC2 instance, again, we need to get, for example, what security groups do they have, if they have open ports, to which IPs. So with this, we are going to get only the information that we need for the incident response. So in here, you can see, for example, that these 2 servers have public IP that has metadata version 1 enabled. Metadata version 1 allows an attacker to retrieve credentials from the server. So a cloud security posture management is not going to tell us that. And with this simple command, we understand that this server is vulnerable. The other thing that we can do, we can dig a little bit deeper with the security groups. So with this, we can understand when was the security group created, which ports are open, and from where. As you can see, the only thing we change is the flag. Instead of targeting EC2 instance, we are targeting the security group from the EC2 instance. And this is going to dive a little bit deeper on the security group. As you can see there, we can see the ports, the ARN, and the different and the tactical things that we need. And lastly, we're going to remove the instance. But I will skip this because of time. Another thing that we can do, as I was telling you, was threat hunting. So, for example, we can do IOC hunting, so we can look for event history logs for different indicator of compromise. So here we are going to retrieve data from event history from AWS with a simple command. It's log retriever, AWS profile for authentication with the region as we did before. As you can see, the command is the same for every module. The only thing that you change is the log retriever from the close status for the incident response or whatever you need. And we can get only the logs that are like part of the attack, for example, if it's a source IP, or if it's an IAM user, or if it's an access key, we can get that quickly. Another thing that we can do for hunting, for example, is we can search for cloud lateral movements. So what this is going to do is it's going to search for specific API calls that we know that are part of an attack of lateral movement. For example, if they are like creating new access keys, or if they are like trying to connect to the AKS clusters, if they are going to authenticate against an ECR repo, all those commands are part of the suite, and we can get that. For example, here we are getting this get authorization token. This get authorization token is something that an attacker can use to connect to an ECR repo to poison a Docker image, and from there to use that image to compromise a Kubernetes cluster, for example. The last demo I have for you is for impairing defenses. So an attacker can, for example, disable detection mechanisms like CloudTrail or GuardDuty as part of their attack. So yeah, with this tool, we can also detect that. We can also hunt for that, and we could create like in some future detection rules for that. So whenever, besides we don't have a SIEM, besides we don't have a closed security posture management, if we get this, we can get a notification and detect this in a faster way, and not whenever we are compromised. For example, here we can see the log for a stop logging API call. The stop logging API call is when somebody disables CloudTrail. And again, we can see the source IP, all the information that the AWS CloudTrail log offer to us. So this is super powerful because besides they have disabled our CloudTrail for us, we can retrieve that information and get that the attacker was trying to impair the defenses. So yeah, this is the tool we are working on. It's still in an MVP status. We are actively contributing to this, and if you want to contribute or download it or use it or give us feedback, I would be more than glad. And yeah, that's it.